Hello guys, welcome to this video. Today I'm trying a new concept. I'm trying to screencast at F4. Let's see how it goes. I'll try to explain the solutions along the way. And if I cannot solve a lot of problems pretty fast, then I will just not post this video. Let's see how it goes. So the first problem, there's a string of length 3 consisting of uppercase and lowercase characters. Check if it is equal to yes, where each letter may be in any case. Okay, I think the better way is just to convert all of them to lower or upper and just check it. Coincidentally, I do not remember how it is actually done, so we can just read about it. No, come on, man. So in C++, right? Just a second. So in general, I was thinking maybe this would help because diff4 should be simple enough for me, and maybe it would be helpful for you if you understand the thought process with which I think for these easy problems. So you just have to use the transform function. So I just write all of s, which is like it just writes begin and end, then s dot begin and to lower. Okay. Now if s is equal to yes in lowercase, then we would say yes, otherwise you would say no. Should be simple enough, I guess. Yep. Let's submit it. Oh, okay, let me try submitting it. Oh, I haven't registered. Let me try to register for the contest first. Contest. Register. Okay, very good. So let me try to submit it. Let's move on to the next problem. ICPC balloons. It's a bit slow with OBS actually, but it's fine, I guess. In an ICPC contest, balloons are distributed as follows. Whenever a team solves a problem, the team gets a balloon. The first team to solve a problem gets an additional balloon. A contest has 26 problems labeled ABCD. You are given the order of solved problems in a contest denoted in string S, where ith character indicates that the problem SI has been solved by some team. No team will solve the same problem twice. Determine the total number of balloons that the teams received. Note that some problems may be solved by none of the teams. Okay. Okay, but you just find out the number of problems the team has solved, and okay, you just find out the number of problems those that have been solved. Those will give you. Okay, so 3 problems have been solved will give 3 balloons, and then you find the number of unique characters. Okay, so what I'm trying to say is that all of these problems represent all of these balloons, like letters, represent that a problem has been solved. So we can just okay, just a second. We can just input them and just see how many unique problems have been solved from A to Z, and those will give the team an extra balloon. So we have the total length of the string plus the number of unique characters in the string, which represent the first solves. So you could just probably do it this way. Um, the get unique function is basically here. Let me just show. So get unique is just sorts and erases the end parts. Just get sorts, gets unique, and erases the part which are like gone. So for example, if I have A B A, get unique will just first sort it to make A B, then take unique to give A B, and thus and then reduce the size, resize it to size is equal to 2. So once we do that, I think the answer should just be n plus int s dot size. That should be good, I guess. With OBS, it takes a bit of time to run compile, but I guess it should be good enough. Let's submit. Okay, both are in queue. That's kind of unfortunate. We wouldn't know if our solutions are actually correct. Problem C. Luca has a cipher made up of a sequence of n wheels, each with a digit AI written on it. On the ith wheel, he made BI moves. Each move is of two types. Up move increases digit by 1, down move decreases digit by 1. Luca knows the final sequence and the moves for each wheel. Help him find the original sequence and crack the cipher. Okay, that is fine. We can just subtract the D's and U's and find the total number of U's and then just subtract. So basically, if we ended up at 4 and we had like 3 U's and 2 D's, we just say finally just count how many U's we have just by subtracting the D's. So I have 1 U. So let's say originally I started up with 3. That's what we can do. So if you are taking the input correctly, it should be good, I guess. So digits shown on the ith wheel after all moves have been performed. So I get 931 and then 9 has 3 Ds. So 10, 11 and 12. Okay, this should be doable enough. We'll consider D as -1 and U as +1 and then just subtract and take mod. So let me try to code it up. So I'm just using some functions to input arrays. You don't need to do it this way, but if you do it this way, it's kind of simple. And here I will calculate the total number of net positive or net negatives that we have. Okay, so let's go. Yn n, right? Int n. Yeah, that's good. That's good. So I take int x, c in x, for then loop over x, then take character by character. Okay, just take character by character. If c is equal to d, then I will, okay, I'll have a counter. So no, the counter is b. Okay, I will just do a b plus plus, else I will do a bi minus minus. Let's try to maintain it like properly. Let's try to maintain it properly. So if bi is less than 0, let's just do bi plus equals 10, if, and then just do bi mod equals 10, yes. So that we have like good maintainable numbers, so we don't get into like -500 or something and trouble ourselves at the end. So now finally just add bi to ai and take mod equals 10. Okay, ai mod equals 10 and then just print it. That should be good enough, I guess, for this problem. I hope I'm recording. Hello, hello. Yeah, everything is good. Everything is good. Yes. It takes a bit of time to run it locally, as I said earlier. Yeah, sounds good. Let's just submit it. Okay, first two are accepted. That's good news. Let's move on to problem D now. Double strings. You are given n strings, s1 to sn of length at most 8. For each string, determine if there exist two strings sj and sk such that si equal to sj plus sk. Okay, note that j can be equal to k. Okay, that is good. Recall that. So I have to print yes or no? Okay, no. Okay, okay. Okay, so for any string, if it is representable as a sum of two different strings, then you say 1, otherwise you say 0. Okay, sounds interesting. Not exactly sure how I would do this. Okay. Maybe we can sort it some way, because only the larger strings have a capability to be equal to smaller strings. Okay. Okay. Not exactly sure. Just a second. A B A B A B A B C A B A C B X X X X. Hmm. A concatenation of two strings. Oh, okay. Length at most 8. Okay, length at most 8 is interesting. Okay, length at most 8 is pretty good because you can just like select how much part you want of a particular string, right? You can just iterate for the first string from 1 to 8 and second from 8. Oh yeah, this is pretty doable, I guess. This is pretty doable. Yeah, I just just didn't read it. I think it's a good indication that I should read problems more carefully. Let's go. Number of strings. Then let's read a vector of strings. V. Okay, how many strings do we have? We have n strings. We will read V. Okay. Then what we can do is we can have a map. You can also have a set, but I don't care too much about it. So let's just use a map, I guess. Because I just want to know whether the particular string is present. So either I can use a set or I can use a map. It's fine anyways. And I cannot have empty strings. That is cool. That is cool. Okay. So what we want to do is we want to go through each of the strings. Then let's say index is equal to their size. V of I dot size. It's at most 8. So what we can do is we can iterate from size equal to 1 and go up to size equal to n minus 1 and just check if that size is fine. So overall size is n, so we want to go till n minus 1. No, wait a second. Yeah, this should be good. Minimum size 1, maximum size n minus 1. Yeah, sounds good. If both of these strings are present, so let's find out both strings. So string s1 is vi dot substring. Okay, I don't remember even the substrate function. Okay, it's kind of like this, I guess. You want the index you are starting from, which is 0, and the length, which is, okay, it must be j over here, I'm sorry. So j, and then the remaining string, which is string s2 is equal to, note that I'm not taking the first or last indexes, otherwise it might just match with itself or something, because you want both the strings to be distinct. So vi dot substr j, right? So just you start with index j, and let's say j is 3 and n is 5. So the length would be 5 minus 3. So it must be n minus j. Should be good enough. Yeah, because total size should be n, so j and n minus j total is n. Now if both of these strings m of s1 is equal to 1 and m of s2 is equal to 1, then I would say my answer, right? So string answer, I would just say, let's just initialize it to all zeros. I hope I'm doing that in the right order, but otherwise we'll just change it up. Answer of I is equal to 1. I could just literally break out of here instead of using some unnecessary time. Yeah, and just print the answer. Should be good enough. If my syntax is correct. Okay, unused variable. I did not use x. Okay, that doesn't make sense. Let's just check the error. Okay, out of range. That is kind of weird. Not sure why. So n minus 1, you start at n minus 1 and you have a length of 1. Sounds good to me. Position 3. Oh, I'm sorry. It needs to be X over here. I'm sorry. Oh, I shouldn't zoom it, right? Otherwise it gets problematic in the... otherwise it gets problematic. Very cool. Yes, this should be correct. Let's try to submit it. Was our C correct? Yeah, our C was fine. That's good. Let's move on to problem E now. I took a lot of time for D. That's okay. F looks simpler. So many people have solved F. I don't know if they're trying to solve it from the back or is it just like very simple. Okay, both look relatively similarly simple, but they're just taking 2 minutes here. So probably should be simpler. Probably F should be simpler. Let's do F first. You're given an array A1 to AN, count the number of pairs such that AI is less than I and AJ is less than J. Interesting. Interesting. AI is less than I, you can find all of these pairs pretty trivially. And AJ is less than J, you can find these pairs pretty trivially. Only thing which needs to be taken care of is this. AJ is greater than I. Wow, nice. Nice, nice, nice. Yeah, this can be doable. This is simple enough. This is very simple. Basically, what you want to do is just store the eyes of all the AIs that are store the eyes of the AIs that satisfy this condition, and whenever J satisfies this condition, try to look in the set how many elements it's larger than how many of those elements. So this should be like simple enough to do. Let's do it. Yeah, integer looks fine over here. Did we pass the tougher problem D? Oh, we got a wrong answer on test 2. I'll probably look at it later. It should be simple enough. I don't think I've made some crucial thinking error. I'll complete F first and then go back to D. Okay? So let's just use longs over here. I don't know why. Maybe we add up some stuff. Okay, now in the set, okay, it's an ordered set over here, right? If you want to find out the number we are larger than, an ordered set would be simpler. Do I have it in the template? Yeah, I have. Okay, this, I don't like this one. I'll search ordered set. Let's look into geeks for geeks. I don't know why I failed D. It's kind of sad, but we'll get to it. Okay, these are the common files. Include them. This is the namespace. Include them. I am a bit suspicious of using geeks for geeks. Sometimes it just bugs, doesn't work, but this should be simple enough. Where does it even say ordered set? Come on. Okay, I just copied it from here. Just copy it from here. Okay. Don't dance. Okay. Copied the ordered set. Why does it say ordered set tree? Okay, let's go. Ordered set. Let's just call it OS. And what would we do? Where is the problem? Okay, let's go. For IN. Okay, yes. Let's store the answer in a long. Okay, so now what I do, if A of I is less than I plus 1, then it satisfies the condition. Then it satisfies our condition. Then we can just, later we'll just add it to the ordered set first. Ordered set dot insert I plus 1. Now what I want is the number of elements which are strictly smaller. So I think that is done by strictly smaller is order of key. So answer plus equals os dot order of key and check for AI. Yes, and then insert it. Finally, it should give me answer. Let's just try. Should be fine, I guess. I don't know why I bugged D. I need to check that instantly, I guess. Yeah, sounds good. Let's submit it. I hope I can pass F at least. Otherwise, this video has to go, I guess. Okay, looking into problem D again. Note that J can be equal to K. Yes, I never disagreed with that. Why does it give wrong answer? Okay, there are a lot of test cases. No, that is fine. Int and CNN vector map string. If I find it, if I find v of I, then I say 1 for it. Okay. String, all of the characters are 0. Then I say it's vector dot size. Okay. Okay, what if I have an okay, then all the strings are non-empty. That is fine. So j is the length, n minus j is the length. Oh, come on, man. It should be x minus j over here. Because the length is x. Okay, I think that is the trivial mistake that I was making. I hope so. Let's try to submit it. F is accepted. Good to hear about that. Okay, let's just wait for D. Okay, it should be fine now. It should be accepted now. Okay, forget about it. It should be accepted. So that was a rookie mistake. Now let's move on to. Okay, is it fine? Let's just check. Okay, it's accepted. Now let's move on to problem E, and then we'll do G. I think this looks like a simple contest. Very simple contest. You are given a square grid with n rows and n columns. Each cell contains either 0 or 1. In an operation, you can select a cell of a grid and flip it. So you can go from 0 to 1 or 1 to 0. Find the minimum number of operations you need to obtain a square that remains the same when rotated 0, 90, 180, 270. Okay, wow. Interesting. 0, 90, 180, 270. Okay. This doesn't look that difficult, right? Just find out what happens after rotating by 90, rotating by 180, rotating by 270, and just check that all of these should be same. Okay. Okay. What happens when we rotate by 90? This guy comes here, this guy goes here, this guy goes here. Okay. Okay. N rows and n columns. Is n even here? No, n is not even. Okay. You can select a grid and flip it. Find the minimum number of observations. Okay. Minimum number of operations so that the square remains same. Yeah, basically we want to find out in 0, 90, 180 and we need to find out all of the pair of squares which give the same value, and we need to choose the one which occurs more in these 4 times and just replace all of the other values there. Let's try to think about how this would work. So let's say I was at I comma j, where would I go? So if I were at 1 comma 1, no, let's not take 1 comma 1, let's take some value in the middle. If I were at 2 comma 2, after rotating 90 degrees, okay, I think I understand. You would go to from I comma j, you would go to n minus j comma I, is it? Probably, right? So you are at, okay, let's just take something which is different. Let's just take something which is different. Let's take this one. Okay, so at the start it was at third row, second column. And then when I flip it by 90 degrees, when I rotate it by 90 degrees, then it would give me if I rotate it by 90 degrees, it would give me what would it give? It would be in the second row, which is the first, like earlier what was the column is would now be the row, and the row number would be just a second, sorry. Okay, it's still in the middle. Why do I always keep choosing things which are equidistant always? Let's choose this guy. This guy looks okay, right? So earlier it was in the uh, second row and fourth column. Then I rotate it and it went to the fourth column would now be the fourth row. So the row number is j, that is fine. And the column number would now be 3, which was the initial row number, right? No, 4. It just goes to 4 too, right? Am I overcomplicating this problem? Is it just simply j comma I? Probably. Then once you just rotate it 180 degrees, it would be okay. I need to probably it's better to just draw these, but I don't have a drawing pad, so I'm just trying to think on the fly. So once I rotate it by 90 degrees, its current column number would be its row number. That is correct. And its row number would be its current column number. Both look fine. Both look fine to me. Then once I rotate it by 180 degrees, it would be okay. Yeah, it would just transpose. So I think it would probably go to n minus j n minus I. For example, this guy was in the fourth row, like the last row and the third last column, and it went to the first row and the third column. Yeah, probably it goes to n minus j n minus. This is my guess. And the last one, I'm not actually sure. 270 degrees. So 270 degrees is just turning the other way around, right? It's 180 degrees from 90 degrees. So is it n minus, what am I doing? N minus, okay. Fourth row becomes the first row. N minus, probably this is n minus I, n minus j. And then this is n minus j, n minus I. You can just test it, just code it up and test it. I think that's a simpler way to test it, but probably not a very ethical way, like probably not the correct way to test it, but I feel this is fine. It should be I j j I n minus I n minus j n minus j n minus I. We should just try it for one particular cell, I guess. Let's try it for this way. Third row, uh, third row, second column. Third row, second column transposes to go to okay. Let me just think. Third row, second column goes to second row, second column. Okay, then I'm totally wrong, right? It goes to second row, second column. Third row, second column goes to second row, second column. Again on rotating, it goes to this guy over here. It goes to second row, third column, and from there it goes to it's hard to explain and think at the same time, unfortunately, but I'm trying my best. it goes to 3 3. Okay, that is interesting. So my logic is wrong over here, and the number of rows is both are 4, 4, 4, 4. Okay, so I comma j goes to, let's look at two examples, and I think from that we can figure it out. Let's look at the last guy over here, that is 4 comma 2. It goes to, where does it go to? It goes to 2 comma 1, second row first column, 3 comma 2. Okay, then it goes to first row third column, and then it goes to third row fourth column. Okay, this is a really nice that it's really great that I did it. I'm like understanding what is actually happening. So I comma j goes to it goes to, j remains the same, and here it goes to n plus 1 minus I. Makes sense? 5 minus 4 is 1. Makes sense. And from here it goes to, from 2 comma 1 it goes to 1 comma 3. Okay, the last term remains constant, so this guy remains constant, n plus 1 minus I, and it goes to 3. Why does it go to, okay, this term is just flipped. Okay, 2 comma 1, 2 comma 1 and 3. Okay, so yeah, this is n plus 1 minus. Okay, you could just mimic it, right? Because it's still 90 degrees for all of them. So the final one must be n plus I minus j, and n plus, and it should just be I over here. These are the four terms, okay? These are the four terms that we have. And now we need to keep maximum of them the same. Okay, it's just 100, right? The size is just 100. Probably I shouldn't have thought so much. No, it's fine, because there are 100 test cases also. Okay, so int n, c in n, vvi grid of n comma vi of n. I want to read the grid, so for n for jn, and how do we do? Char c in c, grid of I comma j is equal to c minus 0. So if it is like the character 1, it will give 1, otherwise it will give 0. Okay, looks good. And yeah, trying to solve it now. So if I'm at 1 1, I need to find all of the characters which have been visited before. So let's have the visited variable as well. So let's just copy it from here. So it's like a vector of a bool visited n comma vector bool n. Okay, initially all of them are not visited, because once we visit a few cells, we don't need to take their opinion into consideration. Like we don't need to calculate them once again, because they're already counted in our answer. So int answer is equal to 0. Okay, so for in for jn, if visited of I comma j, then you just continue. Otherwise you look for all of the 4 guys, and if one of them is not visited, all of them would not be visited, because they all map to each other. So int row value should be I plus 1, int column value should be so sorry for the delay. So let's calculate all of the particular entries. So okay, so these are the first. So R1 C1, then R2 C2, R3, C3. I'll just write them down as we wrote above, and R4, C4. I should have just done it in zero indexing, but I just wrote it in one indexing. So if this is I comma j, this should be row 2 should be column 1, and column 2 should be n plus 1 minus row 2. Okay, and I can just loop over it. So row 3 should be column 2, and column 3 should be n plus 1 minus row 3. Row 4 should be column 3, and column 4 should be n plus 1 minus. Okay, this is not correct, right? It should be row 1 over here, row 2 over here, row 3. Okay, this should be the correct value. So let's find out which is more here, like which ones are represented more over here. So int answer is equal to grid of row 1 minus 1, column 1 minus 1, and then answer plus equals grid of row 2 minus 1, column 2 minus 1, and then just copy paste it. Okay. So now if this answer value is, if answer is less, let's just let's see. If answer value is less than 2, so answer can either be 0, 1, 2, 3, 4. So if it is 2, it is fine. If it is less than 2, okay, why we are using the same variable, so let's just consider total. Let's just call it total. Technically it's better to use longs everywhere, I believe. No, here it can be integers, that's fine. Okay, let's just have this as long. So now if answer is less than 2, I can just, like, in total I will have to add answer. If answer is greater than 2, else if, then in total I will have to add 4 minus answer, else I will have to add 2. Hi. So otherwise I'll have to add 2, and then once I do this, let me just, like, get all of them visited. Let's just say all of them have been visited, so that we don't look at them again. Possibly I'm overcomplicating it, I'm not very sure, but this was the thought that just first came to my mind, and the idea for this video is not to have polished solutions. So let's just call all of this visited. Okay, so all of these are visited now, and finally we can just print total. I hope it works. It just took me a lot of time to code. Yeah, seems fine. Now if this works out, we just have like one problem to go. Or two problems. No, just last problem to go. Okay, all of them are done. Only the last problem is left now. There are n chests. The ith chest contains AI coins. You need to open all chests in order from chest 1 to chest 10. There are two types of keys you can use to open a chest. A good key which costs k coin to use. A bad key which does not cost any coins but will halve all the coins in each unopened chest, including the chest it is about to open. The halving operation will round down to the nearest chest. Okay, any key breaks after uses, that is, it has one time use. You need to use in total n keys, one for each chest. Initially you have no coins and no keys. If you want to use a good key, then you need to buy it. During the process you are allowed to go into debt. For example, if you have one coin and you are allowed to buy a good key worth k, then your balance becomes minus 2 coins. Find the maximum number of coins you can open after having n chests in order from chest 1 to chest 10. Wow, interesting. Let's look at the standings once, just to see if we are doing fine. Yeah, we are doing fine. We are doing a bit slow, but I guess it is fine. We just have to figure out G now. Okay. I guess if K coins and 0 coins. So K can also be a huge number, right? So if our remaining reward is less than, if the reward that we are going to lose is less than K, then we can just use it. Okay. Let's think mathematically. So for the larger chests, it's better just to, okay, for any chest which has more than 2k coins, you are just going to lose k coins. You are going to lose k coins, and otherwise even for this chest it is not good for you to use the bad key. And a good key costs k coins. Okay. So I think let's just sort it. For the larger ones, let's not half it, let's just choose a good key. And when we get to certain points is that the bad key is also not a problem for us. We are not going to lose enough coins using the bad key, then we can just start using the bad key, is what I'm thinking. If you have more than 2k coins, then you don't even need to think about it. If you have less than 2k coins, then we have to think about it. Let's try to think. Okay, I can just sort it first of all. That seems like a simple thing to do. Just using longs. I don't want to get a long error now. Okay, shouldn't be too difficult. Like people have solved it very quickly. We can possibly start from the end. We can possibly start from the end. Okay, no, but we wouldn't know. We wouldn't know. Let's just sort all A and then reverse all A. We can just do that, right? Because we don't want to lose the larger coins for any reason. If at any point we're going to lose k coins, so if at any point if like value of AI is greater than equal to 2k minus 1, then just use the good key. And you can just have like the number of bad keys used, so we can divide by 2 that many times, so we actually know finally what reward we are going to get. Answer plus equals AI minus k. This should be good enough. Now if it is not true, now if we have less than k coins, if we have less than k coins, then we can have like multiple less than k coins. Even if we use one good key, okay, wait, this good key will just help us if for one particular one. For the next one, we still have problems. Okay. So if we have less than k keys at any point, what's the point using a good key? There's no point, because whatever the sum might be, all of the guys after it are going to have a value less than k. Let's just like first calculate the value properly. and just like calculating the value ad hoc. Okay. Okay, if we have less than k coins at any point, then there is no point. Then there is no point using good key, because to conserve the like all of them, to get any value from them, they will have to we will have to use a good key. It doesn't make sense. So I think if AI value is less than equal to k, you should probably just like you should probably just use a bad key. What if the value is between k and 2k plus 1, 2k minus 1? You will get k coins, which is the half. If you have more than k coins, okay, 1 second. If you have AI coins, so AI minus k is equal to AI by 2. So 2AI minus 2k is equal to AI. So AI is equal to 2k. K is equal to AI by 2. So at what point does it become more feasible is our problem. Actually, if our value is less than 2k, so if AI minus k is equal to AI, not 2y, 2k, okay, k is equal to AI by 2. Okay. I'm not sure, I'm not extremely sure, but I just want to check if this works. I unfortunately had to pause the video for some time, but I realized one more mistake, that I can only get it in order from chest 1 to chest 10. So the interesting thing is that whatever good keys I should use it like if I choose to use like 10 good keys and n minus 10 bad keys, all the 10 good keys that I use should be like, yeah, as a prefix, because there is no point having good keys before, since if I have a bad key instead of a good key, like you can just think about it. Like if I just use like 9 good keys first and then I use first good key after some time, then the bad keys in between will definitely just going to hurt me. They are not going to be beneficial. So whatever good keys that I have, those should be as a prefix, is what we can realize over here. So once we do that, we realize that there are only very few bad keys that we need to take care about, because after using a certain number of bad keys, like let's say after 30 bad keys, let's say we have like 30 bad keys, then all of the values are going to go down to zero. Like after 30-40 bad keys, all AI values are going to go down to zero, which doesn't make any sense, right? After that, we can just choose to use only bad keys. I think that makes sense. That is like, because since it's halving every time, so if I use like 30 bad keys, then all of the values after it are going to go down to zero. So we can iterate on the number of bad keys that we want to have. I'm not like completely sure about, yeah, how the problem would work directly, but I think this should be a solution. This should lead to a solution for me. So we won't need to consider too many values, is what I'm thinking about. So we will have a prefix of good keys where we will get all sum of AI minus k times the number of good keys, and after that we can pre-compute the suffix for bad keys. And we don't need to do that for a long enough time, because after a certain point it's all going to go down to zero. all of the values will go down to 0. Okay, now I need to think how to implement that. Let's like we just want to consider it as a sum of two sums. So let's just calculate the prefix sum first of all. VLL prefix of n. Okay, prefix is equal to I. Let's just say prefix equal to I. Then from first to n, prefix of I plus equals prefix of I minus 1. Okay, everything I did earlier was foolish because I have to only go in order, so it's all wrong. So once I do that, I need to calculate the sum the prefix can give plus the sum the suffix can give. So how to calculate the suffix sum? Okay, after a certain point, let's say after 50 times, after dividing 50 times, uh, my sum will never be greater than 0 because that is also not true actually. The first few ways will still be divided properly, and after that it will be 0. Okay, but I need to do only 50 iterations for each n. Huh. So let me try to code this up. So as we can see, the number will go down by to 0 after we just divide it by 2 like more than 40 times. So we just have to compute that particular subset. Like we start at I, then we go to like I plus 50, and after I plus 50 everyone will be 0. So you just have to do 40 into I. You wouldn't have to calculate it too much. That is what I'm trying to code here. Let's compute a few powers of 2 to use directly in our Okay, this number is sufficiently large enough. I think this should be fine. We check with the highest possible value we can get by using this method. So let's say we use like a suffix till I, then you have to also do subtract ki minus 1 times, I plus 1 times, and then for the remaining you can use the prefix. Okay, but the prefix, yeah, that should be fine, I guess. Okay, suffix starting at position I plus 1 should be good, should be good. Okay, but you can have prefix for all of them also, so you just have to do minus 1 over here, and then we can just have like, we can also check it with when we use all of the guys. uh, Probably this should be correct. I'm not 100% sure, maybe I'm doing something wrong, but let's see. Okay, some error over here. Okay, that is fine. I'm not using my macros properly. What? No match to call VLL. Okay, I'm sorry. This is not a function over here. This is a array. So I have to use square brackets. Okay, hi. So we are done with all of the problems. And like I didn't speak much during the implementation of the last problem, but I think the core idea is clear. So let's recap the solutions for all of the problems once again. Let's start from the back. And although I've already explained it while solving, let's just recap it once since it doesn't hurt us. So problem G. Let's check if I'm recording. Okay. So as I said earlier, the interesting thing is that if you divide more than 30 times or 40 times, all of the AIs are going to go down to zero. They will all round down to zero if you divide it by 30 or 40 times. So the thing is that let's say I say you have to use 10 good keys and 15 bad keys, and you have total 25 elements. So where would you want to put all of the good keys? Obviously you would want to put all of the good keys as early as possible, since what a bad key does is that it affects all of the elements after a particular element. So if those elements are as late as possible, they will have as lower a sum as possible. So you have to realize, first fact you have to realize is that all good keys must be used before all bad keys. So let's say now we have to try to iteratively find out where till when we want to use good keys and till when we want, and after that we will start using bad keys. So if I use, let's say, 10 good keys, how much money will I get? I will get the prefix till 10 minus 10 times the cost of a good key. So the total cost I will have to suffer is prefix of 10 minus 10 times k. And how much value will we get from the suffix? Now the interesting thing is that if you were to calculate all of the values of the suffix, like try to divide it by 2 every time and calculate it for every different index, you would get an n squared solution, because you would have to calculate for n bad keys n times. But since the fact I told earlier, when you use more than 30-40 bad keys, let's say you use 40 bad keys, after that all of the values in the suffix are guaranteed to be 0, so you can just break out of the loop. So this is what I essentially have done in the code. Just a second. So I loop for all of the particular values. I want to calculate all of the suffix. So for int is I, like, for value of I is equal to some x, I'm basically going to start calculating the suffix value from index I. Now, if I've calculated for more than 38 values, like the number should be 35, 32, 33, but I've just taken 38 just for safety, then I'll just break out. Otherwise, I will just add the value to the suffix. So how much will a particular person calculate? If it is the first bad key that I'm using, I will get AJ divided by 2. Otherwise, for the next second bad key, I will get AJ divided by 4. So you are basically going to get a value AJ divided by power of 2, which power? J minus I plus 1. And I have already pre-computed all of the values for the power of 2 till 41. So I can use it readily. I don't have to calculate it every time. Even if you calculate it every time, it is fine, but I have just pre-computed it. Then we want to find out the answer. Now what we can have, we can just have all of the keys to be bad keys from the very start itself. So if we do that, we will just get a value equal to suffix of 0. Otherwise, we can have all of them using a good key. If we do that, we will get prefix of n minus 1, which is like the sum of all of the elements, minus k times n. And how to calculate the intermediate values? We iterate from all possible prefix values, and we will get prefix of I minus. So if you do prefix of I, you are basically using good key I plus 1 times. So you have to subtract k times I plus 1. And for all of the other values, you are going to get the suffix. So I will get suffix of I plus 1. So if we compare all of these values and choose which one is the best, that is our final answer. That is how we solve problem J. It was slightly confusing, but once you get the reasoning that after certain point you won't get any benefit from using any benefit from computing. All of the values are going to go down to 0. At that point you can stop computing. F was relatively simple. It was simpler than E according to me, but you need to know how to use an ordered set. So what you want to do is, you can realize the fact that I can just do AI less than I can check it for every particular index. AJ less than J, I can check for every particular index. I just need to find out the number of values AJ such that they are greater than I. So I have an index I and another index J which is larger than I, and the value AJ has to be greater than I. That is the only thing I have to check. So what I do is, for each element I try to figure out if this condition holds, which is like ai less than I. If the particular condition holds, I add it to a set, and among the values which are already in a set, I check the index. I just add the index to a set, and once I get a particular value, I check all of the values which are lesser than that index. So that tells me the number of values for which aj is greater than I, and I already have checked the condition aj less than j and ai less than j before. So I can just add up all of these answers. So you need to know how to use an ordered set. I can link this Geeks for Geeks article. It just tells, ordered set has functionality that it can tell you how many elements exist just smaller than a particular element, or the element at a certain index. It can tell it the very fast, and other properties are similar to that of a set. And you can just sum up all of these answers and get a final answer. If we move on to problem E, E had at least my implementation has a lot of code. I don't know if there are any simpler implementations, but the logic is not very difficult. You just need to know how the rotation happens. So what we want to do over here is, we want to find out how we go from 0 degrees to 90 degrees to 180 degrees to 270 degrees. So I tried to calculate it over here. If you use one indexing, you will, the interesting thing was, the thing you had to do was just pick two different indices and see how they roll. Otherwise I was spending a lot of time trying to figure it out, trying to write wrong answers. But if you just take two consecutive neighbors and see where they go, you will just understand the whole logic. So you would understand that I comma j goes to j comma n plus 1 minus I, n plus 1 minus I, that goes to n plus 1 minus I comma n plus 1 minus j, and that goes to n plus 1 minus j comma I. Actually I didn't even need to calculate all of this. Once I just go 90 degrees, I just have to realize that 180 degrees is just rotating 90 degrees another 90 degrees, and 270 degrees is just rotating 180 degrees by another 90 degrees. I could have simply calculated it. I did not need to do all of this mess. So when I just store it in a grid, and since I'm just getting characters, I'm just getting 0 or 1, I'm just convert it to an int by subtracting it by the character 0. So if my current character is 0, I will get 0 minus 0, which is 0. Otherwise I'll get character 1 minus character 0, which is 1. So I can just fill my grid array like that. Then I want to check all of the guys who have already been visited. We don't want to count them again and again. So the pair of 4 guys which will be changing pair values with each other, we just don't want to have them again and again. So we just use a visited variable to just show that they're already visited, and we don't need to use them. So from 0 indexing I have to go to 1 indexing. So I go to 1 indexing. Then as I explained earlier, I'll just calculate like R1 comma C1 goes to R2 comma C2. I'll calculate R2 comma C2. Then it goes to R3 comma C3. I'll compute that. And then it goes to R2 comma R4 comma C4. We'll just compute that using the same logic. That I comma j goes to j comma n plus 1 minus I. Now I just want to see if there are more zeros or more ones. If there are more ones, we will convert the zeros into ones, and if there are more zeros, we will convert the ones into zeros. So I just see if there are, just compute all of these guys, and if there are if the answer is less than 2, that means that there are more zeros than ones. So we will convert the ones into zeros, and we know how many ones we have to count. That is equal to answer. If there are more than 2 ones, then I know that I can just convert the zeros to 1. So my answer is 4 minus answer. If my answer is 2, I know that there are 2 ones and 2 zeros, so you can convert anything. So your answer will just be 2. And then I said that I have visited all of these guys, I have taken all of their opinions into consideration and calculated the answer. Now I don't need to consider them again. So all of these 4 guys, I will say that they are visited. So I won't, when I go to their point in the loop, I can just skip that point. This is how you solve D, and then just calculate the final answer. Then if we move on to problem D, I was stuck for a moment because I missed the simple fact that the string length has only a maximum size of 8. And I also got a wrong answer because I did not write nx minus j instead of n minus j. That is a silly mistake, but it's fine. So what if the length is just 8? You can just iterate what length string do you want. You can just iterate over, like, I want first string to have length 1, second to have length 7, first to have length 2, second to have length 6, and so on. You can iterate over all of these values. So after you realize that fact, it is pretty simple. You just store all of the strings that you have in a map, so that you can you can know which strings you have and which strings you don't have pretty easily. And am I recording? Yeah. you can know them pretty easily, and then we just iterate over them. We iterate from size 1 to size current size -1, because we don't want any string to be empty. We don't want to have a length 0 or a length equal to the length of the string, because in that case either the first or the second string will be empty. So we iterate from size 1 to size -1, and then just calculate the first string, calculate the second string. If both the strings are present in my map, then I say that my answer is equal to 1, and I just break out of the loop. Otherwise I keep checking. So basically I've just initialized the string with all values 0, saying that no string can be written as a sum of two strings, and when I find such a string, I just change the string character at that index to equal to 1, and then just print the final answer. That was the solution for D. Then if you look at C, okay, if you look at C, we have to realize that uh, all of them had a digit AI, and we made BI moves over them, and they were either up moves or down moves. You know that one up move cancels one down move, so we can just find out the sum total number of moves that we had. And you can see that if you have like two down moves and you reach position 6, then initially you were at position 6 plus 2, that was 8. So then you can just add up the number of down moves to the final answer and appropriately just mod by 10 properly. And if it goes less than 0, just add 10. So what I do is, if there's a down move, I just have another index which will just keep my AI value, which will just keep the ups and downs that I have. So if I have a down move, then I'll just increment the value of BI, otherwise I'll just decrement the value of BI if I have an up move. And I just have to maintain the values to be correct. I can't have BI is equal to -100. That will be very confusing for me. So if my BI goes negative at some point, I'll just add 10 so that it stays between 0 to 9. And if it goes 10 and above, I'll just mod it by 10 so that it again stays between 0 and 9. And finally, I will just add the number of down moves that we have to the final answer and just print the answer. This should give the correct solution. Now if we move on to problem B, yeah, I have written a get unique function that was just to solve fast in the contest. I'll just show. So basically what the problem meant, what the problem understood was that all of the problems, anytime you solve a problem, you'll get a balloon. So you will obviously get n balloons, which are n solves. But if a team solves a problem for the first time, that's the first time that problem has been solved, then that team is going to get one more balloon. So if let's say from A to Z I have 10 problems solved, so for all of these 10 problems, the team which solved them first will get one more balloon. So in total 10 more balloons will be distributed. So we just want to know how many of these problems have been solved. So one way I did that was I sorted the string. So get unique is basically I'll just sort the string first, and then I will calculate unique for the string. But once you calculate unique, you also need to delete the elements at the end. So you do that by using vector.erase unique vector.begin comma vector.end comma vector.end. So this is the entire syntax of using unique over a vector, and then just deleting the garbage space that is created at the end after you use the unique function. So all of that is done using this get unique function. You could also solve it in another way. You can have a vector of characters. You can have a vector with 26 guys, or a bool. So once you see A or B or C or D, just mark it. Just mark that we saw it in the vector. And then for all of the elements in the vector which have values equal to 1, just add them to the answer. So if I have to do it, I'll just do it this way. So I iterate through the string. I don't need to use this now. I'll just iterate through the string, and I will say int x is equal to s of I minus a. You need to minus it with a to get a number between 0 and 26. So once you do that, you could just say that this is a of x is equal to true. I have found a of x. And finally, just see for all of the indices which have an answer of true, just add 1 to the answer. Even that solution will work. But using this unique function was way faster in the contest. Then for A is very simple. You just have to convert it all to lowercase first and check if it is equal to yes. If it is equal to yes, you just print yes. So you could just see out yes and else you could just see out no, and that's how you can just submit it. In general, for in contests, it's like it's better to have a very fast submission. So I just have this define yes, which prints yes and just returns my solve function, and print and no, which just prints no and returns my whole function. So that is how I can just submit it like within a minute or something. But you could just do it very simply like this. I hope this solution was useful. The screencast was useful. I tried to give you an insight into how you can think complex problems fast. Unfortunately, I had to pause the video a couple of times due to some interruptions, but I did not think during those interruptions. All my thinking was done on camera, and I hope that it was useful. Thank you.